Hello everyone, welcome to today's video on solving surface area problems and area of 2D composite figure problems. Okay, so let's review some vocabulary before we get started with examples. So area is a concept you first learned in 3rd grade and then you've seen every year since. Area can be defined as the amount of space a flat 2D shape takes up. We actually already looked at the area of circles, and now we're looking at the area of composite figures and then something called surface area. So composite figures are geometric figures that are a combination of 2 or more shapes. So if you put a triangle and a square together, or a circle and a triangle together, and you try to find the area. And then we have surface area. So surface area is related to area, but it's actually referring to the sum of the areas of all the faces of 3D figures. So if you have a rectangular prism, for example, or a pyramid, you can find the surface area of that 3-dimensional figure by finding the areas of each of the faces, right? So that's like each of the sides of the figure, and then adding those up. So finding the surface area of 3-dimensional figures and the area of composite figures ends up being very, very similar processes. All right, and then really the 2 formulas you're going to need to remember, which you've learned in previous grades for sure, is how to find the area of a rectangle and then how to find the area of a triangle. So you find the area of a rectangle by multiplying base times height, length times width you might have seen as well. You're multiplying the sides together. And then the area of a triangle is 1/2 base times height. Again, sometimes we hear that as length times width, or there's lots of ways to write it. The way we define height of a triangle is kind of particular, but we'll see that when we get to examples. All right, so let's look at example 1. So we're asked to find the area of the composite shape. Okay, and we're given some information, but not a ton. So we're given that this side length is 3, this side length is 4 units, and then this long side length is 8. And we want to find the area of the whole thing. So when we're trying to find the area of composite shapes, we're going to split that composite shape up into its individual shapes that make it up. So I'm going to try to do that here. There's often more than one way to do this, but I see that this composite shape seems to be made up of about 2 shapes, right? Here is a rectangle, and then here it appears to be a right triangle. I went straight down right there, so this is going to be a right triangle. That is going to be important when we're finding the area. And now I just want to make sure I find the area of figure A, which is my rectangle, the area of figure B, which is my triangle, and I'm going to add them together. So for my area of figure A, this is our rectangle, right? So then the formula for area is going to be that my area is equal to the base times the height, or the length times the width, okay? So if I look at my triangle, then I just need to find what are those measurements. So for this side, this is going to be equal to 3 units, and I see this side is equal to 4 units. The way a rectangle works means that if this is 4 units, then the side that's across from it is also 4 units. And if this is 3 units, then the side that is across from it here is also 3 units. Okay? So when I go try to find base times height, I have side lengths, I have a base of 4 and a height of 3. Or it doesn't really matter. That's something that I think students get tripped up with that isn't that important. Height is normally what we think of as up and down, but if you switch the order, it doesn't matter, right? So we need to multiply 3 times 4. I said my base was 4, my height was 3, so my area is going to be what I get when I multiply 4 times 3. What is 4 times 3? 12, and that's going to be 12 units squared, because when I find area, that's 2-dimensional. I have 3 units vertically and 4 units horizontally, so I'm getting this amount of space in A. All of this is my area. Okay, so that is going to be equal to 12 units squared. Okay, now let's do the same thing for figure B. Figure B, I have a triangle. So my area, instead of being equal to base times height, is going to be equal to 1/2 base times height. So the height, what is very important for triangles, is your height has to be measured as the side length with your 90-degree angle. So when I look here, this is my 90-degree angle right there. Okay, and we already figured out that that height is 3 units, because this was 3 units. They're the same, they're across from each other in the rectangle. So 3 then is going to be my height. And then my base is going to be whatever the length of this is. Now, theoretically, you could switch these around. Again, you could think of this as your height and this is your base, but that's a little bit counterintuitive given how the picture is drawn. Okay, so let's figure out what is this length. So we were told this entire length from here to here was equal to 8 units. And then we just figured out in our last problem that this is 4 units. So this 4 plus our missing side has to be equal to 8. So 4 plus what equals 8? You could subtract 8 minus 4. 8 minus 4 is what? 4. Yep, so if this is 4, and this is also going to be 4, and that's going to give us total, that whole length is 8. So that means that our base in this case is going to be 4 units. Okay? All right, so then let's go back to our equation, our formula, and our base is 4, and our height was 3. So we're just going to multiply those to find our area. Okay, so we have 1/2 times 4. What is half of 4? So 1/2 times 4 is 2. So 1/2 times 4 is 2, and then 2 times 3 is 6. So we get 6 units squared. So then we want to find the area of our composite shape, which again, I said is what we get when we add this area of figure A plus the area of figure B. So we're going to add 12 units squared plus 6 units squared. What is that going to give us? 18 units squared. Perfect. So our final area is 18 units squared. Again, how I found this area and how you're going to go about finding the area of composite shapes is we're going to split up our big composite shape into the individual shapes that make it up, and then use our rectangle and triangle equations to figure out the area of those pieces, and then add them all up. For example 3, we're asked to find the surface area of the rectangular prism. You've learned what a rectangular prism is before, but just a quick reminder. So a prism is a solid object that's 3-dimensional that has identical ends, and those ends give you the name of the figure, flat faces, and the same cross sections at all the lengths. So that means if you were to take like a knife and like chop a rectangular prism in half, like across it, you would have this same 2-dimensional figure. So here's an example. This is a triangular prism. You see that cross section is a triangle every single time. And you just like chop it through. Okay, so we're asked to find the surface area of the rectangular prism. What that means, again, is that's the sum of the areas of all the faces of our 3-dimensional figure. So I need to figure out what are the faces that exist in my figure and then find the areas and add them up. Here's one face that I have. This is a rectangle. It's drawn 3-dimensionally, so it doesn't look as much like a rectangle, but we're told it's a rectangular prism, it's a rectangle. And we have a base of 3 and a height of 4. Okay, so I can easily find the area of that. The area of that is going to be equal to base times height, so 3 times 4. Okay, so this is going to have an area of 12. There's one other face that's the exact same as that, has the same dimensions. It's the ones that's across from it. Okay, so that's going to be the case here. So this is its identical end. It also then is going to have a height of 4 and a base of 3. Okay, and that's also a rectangle, so we can multiply the base and the height to find the area of that base. So my area is going to be base times height, so it's going to be equal to 3 times 4, and that equals 12. Okay, and that area, so that's the area of, we'll say, side A here, right, and side B. So that means I have 2 of them, so I'm actually going to multiply that by 2. So in total, we're going to have 24 units squared from side A and from side B. Now, let's try to find it of the other sides, because we have 6 faces total in the shape. Okay, now we can look at these, and I'm going to draw in blue. So here's a rectangle. And then here is another rectangle. These are across from each other. The prisms means they are going to have the same dimensions. Okay, so if I look at that back one, this height was 4, and then my length or my base or whatever is going to be 7. Okay, so I'm going to multiply 7 times 4 to figure out my area. And if that's the case for that rectangle, it's also going to be the case for this rectangle. So I'll do 7 times 4. All right, let me do that. So 7 times 4 is 28. So that's going to be the area of this side and that side. And I have to multiply that by 2 then because there's 2 of them. So 28 times 2 is 56. So to get my total surface area, I'm going to add 24 plus 56. And then there's 2 other sides. So I already got this one and this one in red. We found this area in blue and this area in blue. You gotta try to imagine like a box. You're missing the top and the bottom of the box. We're missing this area and then our bottom area. Okay, so that's what we're gonna need to figure out lastly. So then in green again, these are the top and the bottom of our boxes, the last faces that we need to figure out the area of. Our base and our height are already kind of figured out for us. So I'm going to call this 3 my height, and then I have 7 as my base. Okay, 3 on this side, that means 3 is going to be over here. If that's 7, 7 is going to be over here because I have a rectangle. Okay, and then the same is going to be true up here. If that's 7, that's 7, and if this is 3, this is 3, and then this is 3. So I'm going to find the area by multiplying 7 times 3, my base and my height. What is 7 times 3? 7 times 3 is 21. Okay, so that's the area of one of my faces here, like either the top or the bottom. And then I have 2 of them, so I need to multiply that by 2. 21 times 2 is equal to 42. Okay, and then when I add these up, 24 plus 56 plus 42, so the total surface area is 112 units squared. So surface area is a 2-dimensional measurement of a 3-dimensional shape, right? So we're trying to find the areas of the faces and then just add up those individual areas. Something that some people do is they try to take the 3-dimensional shape and like flatten it out, and then you can find the areas of the individual flattened out faces. I find that flattening to be very hard to do mentally, but some people who can like visualize things naturally are like very good at this, and this helps them. So I'm just letting you know, you can think about taking this shape, like this is the base, and like pulling out this side to become here, pulling out this side to become here, and then pulling out those sides to flatten out if you want to do that first. For me, that doesn't really help me. I just need to like imagine the 3-dimensional box and be like, okay, there's these 2 faces, there's these 2 faces, and there's these 2. But that would be an option for you. Okay, now I just want to set up for you how we're going to do this last example. We're asked to find the surface area of the triangular prism. Okay, so I want to figure out what are the faces, and then we need to find the areas. So I have these triangular faces. Okay, that's one triangle. It's one triangle. They're identical. It's a prism. They're across from each other. They're going to have the same measurements. Okay, so if this base then is 5, and then the height is 6, because we're given that height line creates a 90-degree angle, so that's our correct height of a triangle. So we would multiply 5 times 6, which is 30. And then it's a triangle, so we have to take half of that, and half of that is 15. Okay, so we get that the area of these triangles is 15. So we have 2 triangles that each have an area of 15. So when we have 2 of them, then we're going to have a total area from those triangles of 30 units squared. Then let's look at this rectangle. We're told that this has a length of 5. Okay, they're telling us that this length is 5. So that's like an equilateral triangle there. And then we have a base of 8. Okay, and that's going to be the same on this blue triangle over here as well, our side length. And then if I look at this bottom triangle, it wouldn't necessarily be this way if we didn't have an equilateral triangle as our face, but we do here. So again, we're going to see that this length is 5, and then this length is 8. So we have then 3 rectangles that each have a base of 8 and a height of 5. So we're going to multiply 8 times 5. 8 times 5 is 40, times 3 is 120. So I get 30 plus 120, which in total is going to give me 150 units squared. Okay, good job everyone.